Hello everybody, welcome back to my channel. So today I'm going to go through hypothesis testing using the student's t-distribution. So just a quick note, I'm not going to do any pre-requests just because this is personally for me, because I have an exam in about a month, about 5 weeks-ish time, and I don't want to forget how to do like the hypothesis testing process. So this video is kind of like a backtrack for me, so I can just reference to my video instead of going through every single one of my lecture slides and whatnot, right? So the key benefit of this is probably for me and probably people in my course if they ever find this. But yeah, I'm just gonna expect, you know what is confidence interval, margin of error, null hypothesis, alternative hypothesis. I'm not going to go through like every single nitty gritty bit. And also, since we're doing on Excel, it's going to make it significantly easier, because if we did it on paper we would have to use every single formula and equation. But luckily my test is online and open book, so I won't need to do that unless I want to torture myself for 3 hours straight. But yeah, without further ado, let's just get straight into it. So what we're first going to want to do is clean the data and select what variables we want, right, to hypothesis test. So we have quite a few here, not too many, but quite a few. But what's standing out to me right now is annual income and loan risk. We want to compare these two things, right? So let's just copy and paste these. I'll explain why I chose these later. I obviously didn't just look at it right now. I pre-chose them, but you know what I mean. But yeah, let's make annual income like all currency, because it would make sense, right? So we have our annual incomes and our loan risks. So these are our two variables. So what we're going to want to do is hypothesis test these. And the only way we can hypothesis test them is if we can find the average and then compare it to a value, or we can take variables or subcategories from those variables and compare them, right? So right off the bat, we can see with loan risk right now anyway, there's only two different types of categories. And in order to check that, we can actually just go on, we just highlight, I think for now, data and filter. If we just use the filter tool, we can actually see that there's only two different types of variables. But if you're unsure, you can still use this same technique and all your variables should pop up here, right? So if you had 3, you'd have another one here. But yeah, so we don't have any blanks, so that doesn't really matter. Well, we might do, but we don't know. But I'm just assuming we don't have any. Anyways, right, so what I want to do is basically split off fully paid annual incomes and charged off annual incomes into 2 separate columns, because right now we have every single individual who's on this database in one column, and that's not really going to help us unless we're trying to find the general mean, right? So I'm not going to show you how to do the general mean, because I'm already going to show you how to do the means of the subcategories. So it'll be the same thing, right, if you're trying to find the general mean. So just to start off, what I'm going to do is highlight A and B columns, click on loan risk and this like toggle button here, and then let's put fully paid first. So we'll untick charged off. So all the individuals who are under this category or type of loan risk of fully paid will only occur. Everyone else will be removed from the list, right? So we copy this and paste it over here, and we can do the same for charged off, right? So if we copy this, paste this, get values here, perfect. And yeah, so now we have 2 columns. So let me just unfilter this before my Excel crashes. There we go. Okay, so what we have here, just as like a review, we have our annual income and loan risk of every single individual from the database or the sample or the population event, sorry. So you have every single one. And in our second column, we have every single individual's annual income who's under this category of fully paid. And then in this column over here, we have every single individual's annual income of everyone who's under the category of charged off. And that's great, because now we can do some comparisons between these subcategories, right? So just for like better reference, I'm going to put fully paid, and then I'm going to put charged off. And then what I can do here is delete these 2 columns, because we know that everyone on this D column is under this fully paid loan risk thing. and then everyone on the F column is part of this charged off low risk type, right? So you just delete those. And then we can make this larger so we can see everything. Move this over here. Hopefully Excel doesn't crash, thank God. I've had some bad times tonight. But anyway, here we go. So we have the general and we have our subcategories. So for my first hypothesis test, I'll be going through the one-tailed and the two-tailed, but we'll do the one-tailed first. Let's just say that the annual income of people that have fully paid off their loan or whatever this is about, don't really care about the context because this is AI generated data. But anyways, yeah, annual income from fully paid status people is more than people that have been charged off, right? Let's just assume that. So what we're going to need to do first is find the mean of both. So what you can do is highlight both D and E, click data, if you haven't imported the data analysis tool pack, I have a YouTube short showing you how to do that. So go and do that if you haven't done it. Click on that, go on to Descriptive Statistics, click OK. Then you have your input range, which is what we have here. Also, if you don't know what I'm doing, there's another video on my channel. I'll put it in the iCard or something at the beginning of the video. So just rewind back and watch that. And yeah, so I won't be going through everything like one by one, as I said earlier. So we have labels, output range. We'll just click this here. Summary statistics. Don't really need it. I meant the confidence level for mean. I meant you have to have summary statistics on because otherwise it won't work. But yeah, I mean I can show you right now. It won't work. Yeah, okay. So I have to have it on. Click OK. This might take a while. I've literally got like the most powerful MacBook to exist, but for some reason it still takes decades for it to work. I don't know why. Okay, it finally worked. I think the reason why it's taking so long to summarize everything is because this data spreadsheet is humongous. But anyways, let's just spread everything out. We can also delete this column because it's just the same as this column over here. So delete that. Move the data so it's corresponding to the title. Same here. And then we'll expand these. Okay, nice. Very nice. So we have some summarized statistics over here of the mean, standard error, median, mode, standard deviation, But what we're most attracted to or need are the means, right? So let's just highlight these. Let's also put everything to 3 decimal places. Whoa, 3 decimal places. We'll put these to 2 because it's annual income. You gotta remember the context, right? So oops, I have a bad habit of saving everything every time I do something. But anyways, on track, we have our means here. So we have our fully paid mean and our charged off mean. You can check if you don't believe this is true. I mean, it's literally a computer, but you can check by doing equals average and then clicking the column. I won't do that now because it'll probably crash Excel and I don't want that to happen. But yeah, so now we can start our hypothesis tests. So what we need for the t-test hypothesis is the t-statistic and critical value and obviously a confidence level. So we're not given a confidence level in this question because I made it up. However, hopefully in the actual exam it'll be like, so using a 95% confidence level, a confidence level is basically just how accurate your data is. So the closer it is to 100, the more accurate it is because there's less space for error, right? So first test, so we have our null hypothesis. So we'll say average and income, I should put inc, of fully paid is equals to average annual income of charged off. Okay, that's the null hypothesis. Everything in the null has to equal something, right? And then we also have our alternative. So it'll just be the same thing pretty much, but H1 and more than. So for a first or one-tailed test, you can have a alternative hypothesis which is more than, or you can have a alternative hypothesis which is less than your other do you call this, other value you are testing. There we go. So yeah, but we're going to assume that our fully paid average annual income is more than the average annual income of a charged off. So what you're going to want to do is find a t-statistic, and the t-statistic is equals to your sample mean subtract your well, we'll call it test mean, but the actual name isn't test mean because this is the test mean, but you get what I mean, right? Hopefully you do. And then you can do divided by standard error. Okay, so that is the equation for a t-stat. So here our t-stat would be, oh, why has it done that? Would be equals to, because we are testing this one, this is our sample mean, right? So it's this, if I put brackets just in case, subtract our test mean, because this is on the right side and it's the thing that we're trying to compare to our actual sample, right? So we subtract this divided by the sample standard error. So not this standard error, because we're not using this as the, if you must, the control variable, right? We're using the fully paid, right? So we'll do divide this side, the fully paid standard error. So we get t-statistic of 10.385 . We'll make it to 3 decimal places just to make it easy, right? Let me just state that we're using a 95% confidence level because I forgot to mention that. Sorry about that. So yeah, we're using a 95% confidence level. So this is where we should find the critical value. So the critical value is equal to t.inf for a one-tailed test. For a two-tailed test, it's slightly different. But yeah, so critical value equals t.inv, comma, 0.95, comma, so the degrees of freedom is just the count subtract minus 1, right? Because it's the number of observations in a sample subtract 1. So in here, in our case, would be 25714, right? So that's what our critical value will be. So we just do t.inv, comma, 0.95, comma, 25714. And we get a critical value of 1. And there we go, 1.645, right? So we can see clearly that the t-statistic is more than the critical value by just a little bit, right? So our conclusion can state that since the t-statistic is more than the critical value, we have enough evidence to reject H0 in favor of the alternative hypothesis H1 at the 5% significance level, right? So that just suggests that they don't equal each other and that actually the average annual income of fully paid people is more than the average annual income of people who have been charged off. And most of the time you'll be able to visually see that that is true, because like here, right, if we just zoom in, I mean, it's quite obvious that 69.7k is more than 65.6k, right? It's a funny number. Anyways, yeah. So you can clearly see that one is more than the other, but like the reason why we do hypothesis tests is for two samples, or to compare with something else like the price of milk or something like that, right? Just as an example, if they're very close in value, or closely linked, I was going to say, but close in value, right? If there's little difference, if it's like comparing 36.487 and 36.465, is there enough difference at the significance level or confidence level that we're using? Is there enough difference to suggest that they are the same, or if there is enough evidence to suggest that they're different, right? So that's why we do hypothesis tests. But here, I mean, it's quite obvious, but sometimes it's just better to just in case, just to check if they're different or not. Sorry, I'm just going on a tangent right now, but you know what I mean. Okay, so that's the first test. So we verified, obviously, that the t-stat is more than the critical value. So that's fine. So test 2, we'll probably already know the conclusion, but because of, revision purposes, I will do a second test. And again, I'll use a 95% confidence level. Okay, you know what? Let's use a 99% confidence level just to see if there's a difference, right? So this basically means that the significance level will be 1%. So just think the significance level is 1 minus the probability of the confidence level, and you get your significance level, right? So instead here, we're going to be doing a two-tailed test. So let's make our null hypothesis. This will still be the same as the first one, as the first test, right? Because we're not changing anything. We're using the same variables, right? So the only thing that will change is the alternative hypothesis, which is H1. Or I'll just copy and paste it again, actually. Right, so it'll be H1, which is the alternative hypothesis. But instead of having more than and less than, we're going to have a not equal symbol if the emoji thing comes up. There we go. Okay, so here we have equals, and alternative is not equals, right? So for a two-tailed test, you can only have not equals. You can't have more than, less than or equal to, or more than or equal to in a two-tailed. It's only not equal to. That's when you use a two-tailed test. And the difference between a one-tailed and a two-tailed test is the one-tailed test will see if it's more than, if you use the more than inequality, and then the negative axis, if you must, for the less than inequality, right? But for the two-tailed test, you look at both sides of your distribution. So you have the positive and negative, and then for that, if you're doing it by paper, you have to divide the significance level by 2 so you can measure both sides equally. But obviously we don't have to do that because we have it in Excel, which is lovely. So yeah, we can just basically just find our t statistic and critical value and be done, right? So here, our t statistic, it will be, this time is a little bit different. I just realized. So what we have here is we still have to find the t statistics, obviously, but in Excel, we can do data analysis, and then t-test of 2 sample assuming equal variances or unequal variances. And in order to check that, we can just go back up to our descriptive statistics, see if the variances are the same. They're clearly different, right? There's 4 here and 2 here. Okay, so they're definitely different. So we'll do data analysis and t-test 2 sample assuming unequal variances because they're not equal, right? Unequal. Click OK. Then you have variable 1 range, variable 2 range. So, oh, just threw my mouse on my desk. Sorry about that. So for here, we don't even need to use the descriptive statistics table. We can just go back to our so-called raw data that we've sorted out. Click our variable ranges, you know, D and E. They have labels on the top, so I'll add, like, tick the label box. Hypothesize mean difference 0. Don't ask me why, just is apparently. So I've just gone with that. And output range, I should put this. We'll put it here. Okay, click OK, and then there we go. Okay, so because we're testing that the annual income of fully paid people, we click this input range first, the D column first, and then because we're comparing it to charged off, we click E second, because there's a difference if you click E first and then D first. These 2 columns will be switched, but yeah, just a quick note there. So here again, it shows us the mean, the variance, and different things below. We basically just need the t statistic, and that's basically that's basically it. But okay, there we go. Okay, so we have the t statistic here. It can also be found using an equation. So what we can do here is do equals. So I know Excel, all my days. Is equals to the difference between what you're testing and what you're comparing it to's mean. So it'd be this, subtract this, and then you divide it by the square root of everything, right? Okay, yeah, sorry about that. I should have cut that out. So basically what I was trying to do was find the difference between our mean of what we're testing to what we're comparing, divided by square root of everything of the sum of the standard errors. And the standard errors is simply calculated by the variance divided by number of observations, and then we did the same thing here, right? So that's what I was trying to do, and my brain wasn't working. So yeah, when you click enter, you can see bring it to 3 decimal places. We have the same thing here. So, but Excel just does it for you. But if you need to, worst case, there you go. Just correspond the colors, honestly. Okay, so we've got that out of the way. If I could delete this, there we go. So to find the t-statistic, we've done that. It's 5.144. So we'll copy and paste this down here. And to find our critical value, it's slightly different this time. Nothing too much of a nightmare, but it's just another formula we need to remember, which is t equals t dot inv dot 2t. So obviously it means inverse function of t in a two-tailed test. That's why it's dot 2t, right? And then it's the same thing as before. Yes, I know Excel. Okay, right, so probability, we're using the 99% confidence level this time. So our probability will be 0.99. And degrees of freedom is getting the whatever we're trying to observe, or not observe, trying to test, sorry. It'll be that subtract 1. So here again, it'll be 25714 like previously. Click enter. We'll make this 3 decimal places also. I don't think it'll make much of a difference here. But yeah, as you can see, again, the t-statistic is more than the critical value. So our conclusion here is that our modulus t-statistic is more than the critical value. And so there is enough evidence to reject the null hypothesis in favor of the alternative hypothesis at the 1% percent significance level, right? So another thing for two-tailed tests is the t-statistic, because you're looking at both sides, as I said earlier, it has to be the modulus of the t-statistic. So even if this was negative 5.144 and 0.013, you'd still have enough evidence to reject H0 because you're finding the modulus, the absolute value of the t-statistic. So it doesn't matter if it's negative or positive. If it's more than the critical value, then you're fine. So yeah, that's basically how you do the one-tailed and two-tailed hypothesis test all in one video. Hopefully that made sense to other people that isn't me watching this, because I know my explanations weren't very clear, but if you don't understand something, hopefully you can use the uni resource or just rewind my video and watch it back again. But yeah, I might write like a summary in the description or something. But yeah, hopefully you found this video helpful, and I'll see everyone later.